Three great questions to see if you really understand forces are: can you draw the force diagrams, firstly while the ball is stationary before launch, secondly during the launch, and thirdly after the ball has left the person's hand. It's good to let students try each one, go through it, and then let them try the next one. So pause the video and try the stationary before launch one. Hopefully you realised that there is a weight force down, or a force of gravity down, and a normal contact force from the hand up. And they must be the same size to give a resultant force of 0, which is why it stays stationary. I'm simplifying things slightly by ignoring this thumb, which might be applying another small force. Now pause the video and try the second part. Can you draw the force diagram during the launch whilst the ball is still touching the hand? Hopefully you realised that the weight and the normal contact force from the hand are still there. But we have an additional contact force from the hand acting forwards, which means the resultant force is forwards, which causes the ball to accelerate forwards. It's worth emphasising that that forwards force comes from the hand. That will help with the last part. So can you now draw the force diagram for the ball after it's been launched? Pause the video and try that now. After launch, the weight still acts down on the ball, but the normal contact force from the hand and the force forwards from the hand have both been removed because it's no longer touching the hand. There will also be a small air resistance or drag force acting in the opposite direction of the ball's motion, which will be to the left. People often mistakenly think that there must be a force forwards, which is what's making it go forwards. You need to remember that the reason that it's moving forwards is because in the past there was a forwards force which caused it to accelerate, and you must remember that forces change the motion and are not necessarily needed for something to be moving. To challenge this misconception, it's really useful to have emphasised in diagram 2 that the normal contact force came from the hand and the force forwards came from the hand, because then you can say, well, in this picture, after launch, the hand is no longer touching the ball, and so it can't be causing that forwards force anymore. So after launch, the resultant force will be acting in this direction, which is almost down, and that causes the ball to accelerate down towards the ground, which is indeed what we see happens if we watch it again. Before launch, the ball is stationary. During the launch, the ball accelerates forwards, and after launch, the ball accelerates down. I hope that this video helped to improve your understanding of forces, or you can use the ideas from it to help to improve your students' understanding of forces.